Good evening. Sum number 5 from exercise 4.3. In the expansion of k plus x raised to 8, the coefficient of x raised to 5 is 10 times the coefficient of x raised to 6. Find the value of k. So we begin with general term in the expansion. What is that? tr plus 1, 8cr, k raised to 8 minus r into x raised to r. Now finding term in x raised to 5 and then x raised to 6 is easy. For term in x raised to 5, r must be 5. So what will be that term? 8c5, k raised to 8 minus 5, x raised to 5. And term in x raised to 6 will be for r equal to 6. So 8c6, k raised to 8 minus 6 into x raised to 6. Now we use the condition that coefficient of x raised to 5 is 10 times the coefficient of x raised to 6. So 8c5k cube is 10 into 8c6k square. Now use NCR formula. You get this. Now 6 gets cancelled, 7, 8 present on both sides. So they get cancelled. So k is 10 upon 2, which is nothing but 5. Next one is good one. Sum number 6. Find the term containing x raised to 6 in the expansion of 2 minus x into 3x plus 1 raised to 9. Actually, if we expand this, we get 2 into this. So in the expansion of this, we have to consider a term in x raised to 6 so that its coefficient can be obtained. Then minus x into this. So in the expansion, we have to consider a term in x raised to 5. Why? Because we have to multiply it by x so that it becomes a term in x raised to 6. Right? So I have omitted one or two steps. Write the expansion of 3x plus 1 raised to 9. It is 3x raised to 9 using binomial theorem, of course, plus 9c1 3x raised to 8 plus 9c2 3x raised to 7 plus 9c3 3x raised to 6 plus 9c4 3x raised to 5. I'm not interested in the remaining terms because I'm asked to find coefficient of uh, coefficient of x raised to 6 so that I can attach x raised to 6 to it to get the required answer. Okay. Now, if I open the bracket, then I should be interested in which terms? 2 into this 9c3 3x raised to 6 because it is in x raised to 6. Okay. Now, I should be interested in one more term, which is that. See, minus x, when it is multiplied with these many terms, consider this one, x into x raised to 5 is x raised to 6, and that is why I have written minus 9c4 3 raised to 5. This is actually coefficient of x raised to 6. Now it is asked, find the term containing x raised to 6. Okay, so we have to mention x raised to 6 also. But at present, we will obtain coefficient of x raised to 6. Now tell me the value. So it is now it is up to you how to simplify this. 9c3 is this is 9c4. I have taken 3 raised to 5 common. That is why this is 3 into 168 because 3 raised to 5 is taken common. So 3 into 168 minus 126. So this is 378. 3 raised to 5 is 243. The product is this. So the term containing x raised to 6 is this 91854 x raised to 6. Sum number 7. Just listen to me. The coefficient of x square in the expansion of 1 plus 2x raised to m is 112. Find m. This is simple one. First find general term in the expansion. It is what? mcr 1 raised to m minus r 2x raised to r, but 1 raised to is 1. So it is simply mcr 2 raised to r x raised to r. Now for this term to be in x square, why x square? Because we are asked to find the coefficient of x square. That is why. So r has to be what? 2, right? So what is the coefficient in that case? It is mc2 2 square, but it is given to be 112. Now it is MC2 m factorial upon 2 factorial into m minus 2 factorial. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. Simple. So m minus 2 factorial gets cancelled. So m into m minus 1 is 112 into 2 upon 4, that is 56. It is written as 8 into 7. Usually we write this as m minus 1 first and then m, so that we can argue that this is product of consecutive natural numbers. So we express 56 in that fashion only, 7 into 8. But here numbers are written in decreasing order. So m minus 1, so 8 into 7. So m must be equal to 8. Now we discuss binomial theorem for any real index. See the title, any real index. Actually, we know this statement for binomial theorem. Now, why can't we use this statement for any real index? For the simple reason, if n is say a fraction, then NCR is not defined, right? Now for that, I will say, what is NC0? 1. What is NCN? 1. What is NC1? N. What is NC2? I can prove that it is n into n minus 1 upon 2 factorial. Similarly, what is NC3? N into n minus 1 into n minus 2 upon 3 factorial, and so on. Now the same binomial theorem I can write as a plus b raised to n is a raised to n plus n a raised to n minus 1 into b plus n into n minus 1 upon 2 factorial a raised to n minus 2 b square plus n into n minus 1 into n minus 2 upon 3 factorial a raised to n minus 3 into b cube plus dot dot dot. Now listen to me carefully. If n is a positive integer, say 2 only, then in the fourth term, n minus 2 will be there. In fact, 4 term onwards, in all the terms, n minus 2 will be there. And therefore, number of terms is limited. You also know that if index is 2, then there are only 3 terms in the expansion. Suppose index is 10, okay? Then there will be 11 terms. Why? Because in 12th term onward, n minus 10 will be present. So 10 minus 10 is 0, 0 into. So it is 0. But this is interesting. If n is not a positive integer, that is natural number, then what will happen? Then the process never ends, and therefore this becomes an infinite series. I repeat, if n is a real number which is not an integer, then none of the coefficients will be 0, and the expansion will contain infinitely many terms. So it will be an infinite series. Okay, I hope you understood this. So this is the binomial theorem for any real index. Yes, so we have proved the binomial theorem when the index n is positive integer. We now study the expansion of a plus b raised to n, where n is any real number. It is given below. We accept it without proof. But I think I have explained the logic behind that. A plus b raised to n is a raised to n plus na raised to n minus 1 into b plus n minus 1 by 2 factorial a raised to n minus 2 b square, and so on. See, this is the general term. You have to use common sense. When index of b is 3, the last term subtracted is 2. So when the index of b is r, last term subtracted is what? R minus 1. So n less r minus 1. That is why n minus r plus 1. But if you do not understand this, no problem. Just consider plus this plus dot dot dot. Now remarks are interesting and important. The first one, if the index n is a positive integer, then every term after n plus 1th term will contain a factor n minus n, which is 0 in the coefficient, and hence the expansion will contain only n plus 1 terms. Yes, if n is positive integer, number of terms is one more than the index. Index is n is positive integer, so number of terms is n plus 1. But if n is a real number which is not an integer, then none of the coefficients will be 0 and the expansion will contain infinitely many terms. It will be an infinite series. Okay. Now this is second part, you can read afterwards. The third point is important. If n is any real number and a equal to 1, b equal to x and modulus of x is less than 1, then 1 plus x raised to n is 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial into x cube and so on. I'll explain the logic behind this. See, we are interested in finding, this is important, we will be using this in 12th standard also, 1 plus x raised to n. See, use this. So 1 raised to n, that is 1 plus n, b is x, so 1 plus nx plus n into n minus 1 upon 2 factorial x square and so on. But one condition is there, which is that this can be used if modulus of x is less than 1, obviously, because see, if I ask you to find, say, 1 plus minus 2 raised to half, is this real? No, it is not. Why? Because 1 plus minus 2, if I take value of x as minus 2, this is minus 1 ka root, which is not real. It is an imaginary. It is an imaginary number, right? And that is why modulus of x should be less than 1. What is mod of minus 2? 2. Is 2 less than 1? No. So we cannot use this. This is the simple reason. Okay. Yes. So you have to remember this. 1 plus x raised to n is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial x cube and so on. Here there are infinite number of terms in the expansion and the general term is this. If you can remember this, fine. Otherwise, if you are asked to find sixth term, then it will be t 5 plus 1 and so on. Fourth point, if modulus of x is less than 1 and n is any real number, then 1 minus x raised to n. Same logic, terms are alternately positive and negative. Fifth point, if n is any real number and if you are asked to find a plus b raised to n, within bracket take a common. So you get a into 1 plus b upon a raised to n, which is a raised to n into this. Now compare this with 1 plus x raised to n and so on. Okay. Yes. So these are the points which you should know. Then particular expansion, you need not remember this, because if you know 1 plus x raised to n, then you can find 1 upon 1 plus x by writing it as 1 plus x raised to minus 1 and so on. So these are the 6 series. I repeat, you are not supposed to remember this. This can be obtained easily. For example, root of 1 minus x is 1 minus x raised to half. One more thing, you have to write everything in the numerator. Don't say that let us expand this in the denominator. No, you have to expand this by writing it in the numerator. Now compare this with 1 plus x raised to n. N is half and x is to be replaced by what? Minus x. Simple. Before we start solving sums from exercise 4.4, write down this 1 plus x raised to n. So this is quite logical because this is the expansion of a plus b raised to n only. The only thing is NCR is written in this form. For example, NC0, that is by 1, NC1, that is by n, and so on. Write down this. Okay, the first one, 1 plus x raised to minus 4. You have to use brackets. So 1 plus nx means 1 plus minus 4 into x plus n minus 1 by 2 factorial x square plus n minus 1, n minus 2 upon 3 factorial x cube. That's it. Because we are asked to find first four terms only. Okay. Now finally it is 1 minus 4x plus 10x square minus 20 x cube plus dot dot dot. Third one, 1 minus x square is to minus 3. So n is minus 3 and x is what? Minus x square. Please use brackets. So 1 plus nx, put minus 3 in a bracket. X is what? Minus x square. Plus n minus 1 upon 2 factorial x square. But here x is minus x square and so on. So finally, first four terms are 1, 3x square, 6x raised to 4, 10x raised to 6. So this is 1 plus 3x square plus 6x raised to 4 plus 10x raised to 6 plus dot dot dot. Fourth and fifth for homework. I'll give the answers. So these are the answers for homework sums, fourth and fifth. Now second one, state by writing the first four terms the expansion of the following where mod b is less than mod a. First one. Now within bracket take a common. So a into 1 minus b upon a raised to minus 3. Laws of indices. So a raised to minus 3 into this. Now we are given that mod b is less than mod a. So we can use expansion for 1 plus x raised to n. So it is 1 plus, what is n? Minus 3. What is x? Minus b upon a. Simplify. Tell me the final answer. So the final answer is a raised to minus 3 into in bracket 1 plus 3b upon a plus 6b square upon a square plus 10b cube upon a cube plus dot dot dot. You're not supposed to open the bracket. Second, a plus b raised to minus 4. So within bracket take a common. So a into 1 plus b upon a raised to minus 4. So a raised to minus 4 into this. Same 1 plus x raised to n where n is minus 4 and x is b upon a. So you should get this a raised to minus 4 into 1 minus 4b upon a plus 10b square upon a square minus 20b cube upon a cube plus dot dot dot. Do not open the bracket. So what is the answer? A raised to 1 by 4 into in bracket 1 plus b upon 4a minus 3b square upon 32a square plus 7b cube upon 128a cube plus dot dot dot. Fourth and fifth are for homework. These are the answers. Third one, simplify first three terms in the expansion of the following. See, we will be doing only third part. So it is 2 minus 3x raised to 1 by 3. Within bracket take 2 common. So it will be now 2 raised to 1 upon 3. 1 minus 3x by 2 raised to 1 by 3. Compare with 1 plus x raised to n is 1 by 3. X is to be replaced by minus 3x by 2. Only first three terms are asked. So it is what? 2 raised to 1 by 3 into 1 minus x by 2 minus x square by 4 and so on. We'll solve remaining sums in the next lecture.